let's have a look at how to factorise single brackets. So the first thing we need to remember is that expanding and factorising are opposite of each other. So what we've looked at before was how to expand. Now we're doing the opposite, and we're taking something in its expanded form and we need to convert it back to its factorised form. So to factorise, we need to find the highest common factor of two or more terms. So that means it could be that we're looking for coefficients that they have in common, and we could be looking for variables that they have in common. So we've got to be aware of both parts. So let's just start by looking at the highest common factor of 15 and y. So if I take 15y and think about, right, what are the common factors of that? So I could do that as 1 times 15 times y. I could have, I could have 3 times 5 times y. So those are the two different ways that I could multiply some numbers together to end up with 15y. So that means the common factors are 1, 3, 5, 15 and y. Now I want to look at 10y. And I want to think, right, what are the common factors of 10y? So I could do 1 times 10 times y. I could do 2 times 5 times y. And that would be the only ways that I could get it. So therefore the factors of 10y are 1, 2, 5, 10 and y. What I need to do now is combine this, and I need to look for common factors. So I'm going to look at these two lists, the green and the blue lists, and I want to see what do they have in common. So they've both got a 1, they've both got a 5, they've both got a y. So I need to consider what is the highest common factor in terms of the number and in terms of any variable. So in this case, my highest common factor is 5 and y. I need both a coefficient, the constant value coefficient, and the variable itself. So now let's extend that to doing this. So we know we've found that the highest common factor, let's break that down again. Right, so 15y, read the question. We can do 1 times 15 times y. We can do 3 times 5 times y. Now look at the number 10 and say, right, to get to the 10 I can do 1 times 10, or I can do 2 times 5. So therefore I need to think, well, what do they have in common? They've both got a 1, they've both got a 5, and that's the only things that they have in common. So that means the highest common factor is, in this case, 5. There isn't a variable that's common to both, it's only a number that's common to both. So what I want to do now is I want to take this expression, 15y plus 10, and I want to rewrite that using that highest common factor. So I can write 15y as 5 times 3y, plus I'm going to write 10 as 5 times 2. So I'm writing it using that common factor. What I now do is I look at those two terms. So there's one term and there's another term. And I look at those two terms and I think, what do they have in common? Well, they've got 5 in common. So I'm going to take that factor of 5 out. So I'm going to remove a 5 from both of those. Then I'm going to see, well, what's left over? I've got a 3y plus a 2. And that's what goes in the brackets. So that is our factorised form. We can check our answer if you're not sure. We can expand it out. So if I do it the opposite way now, I can go 5 times 3y will give me 15y, and 5 times 2 would give me plus 10, which is what we started with. So we know we've got that correct. Let's have a look at a slightly more complicated example now. So now we've got to think about the numbers and each of the letters that they have in common. So for the first term, 6a squared b, we can do the common factors. I can do 1 times 6 times a times b. I can do 2 times 3 times a times b. And that's my common factors, well, of that. Now I can look at the common factors of 2ab squared, and that would be 2 times 1 times a times b, and that's the only common factor. So now I need to look at those lists and say, well, what do they have in common? So there's a 1 that's common to both, there's a 2 that's common to both, I've got an a that's common to them all, and I've got a b that's common to them all. So that means my highest common factor, the highest number, is 2. And then I look at the letters, and I've got one a circled in each, and I've got one b circled in each. So my highest common factor is 2ab. So let's think about now how we would factorize that. So I'm going to write 6a squared b as 2ab times other stuff. So 6 is the same as 2 times 3. A squared is the same as a times a, and I've already got the b dealt with. Take away 2ab times, so I've already, the 2 has been dealt with, the a has been dealt with, the b has been dealt with, and then I've got a squared, so I've got a b left over. So now I'm going to take this 2ab that is common to both, and I'm going to write that out in front, and then I'm going to put everything else in my brackets. So what have I got left over? I've got a 3a take away b, and that's the factorised form of it. Now that method might be not quite your cup of tea. Let me show you a slightly different way of doing it, an alternative way. If I write that as 6a squared b minus 2ab squared, I can just write this out in its full expanded form. So I still want to find the highest common factor of 6 and 2, and so I'm going to write 6 as 2 times 3. Then I'm just going to do it times a times b minus 2 times a times b times b. So I'm just writing it all out in full. Now I'm going to think, what do they have in common? So I've got a 2 that's in common, I've got an a that's in common, and I've got a b that's in common. So I'm going to take those three things out, 2, a and b. And now in the brackets I've got to think, what's left over? I've got a 3 and an a, take away a b. And there's the same answer again. So two slightly different ways of looking at it. You decide which method you prefer.